And what I did want to emphasize is like, normally when I see tasks like this, I think about supervised fine-tuning, which is what Travis was talking about earlier. It should be a good fit for a task like this. But unfortunately, one of the most interesting problems is that there is no open data set for a task like this, even though people are interested in it. And so, supervised fine-tuning is unlikely to work well because we don't have enough data. And so that's actually where, a task like this is now possible through this new idea of reinforcement fine-tuning. And here's here's why actually this task in particular is a really good fit. The first is that we obviously lack a large data set and one that has input and output pairs, so it's labeled. But with reinforcement learning, because it's an online algorithm, I'll show you what that means in a moment. You can essentially just hand curate 10 examples by yourself and create a data set out of that. And that is enough to get started, right? Very, very simple. The second is that because we're writing code, code is inherently verifiable, right? And it's objectively verifiable in that code always executes the same way most of the time, right? And in our case, what this means is that we could have something write kernels and then maybe write something like test cases, run it against the code and see if it compiles and produces the same output. So we have a mechanism that we can devise to basically grade the quality of the output that the model is producing. And the third is that, large search spaces, this problem is like, it has many different solutions because you can go all the way from getting it correct to optimizing different parts and, for different matrix sizes. And there are analytical solutions, but it requires very deep expertise. But reinforcement learning balances this idea of exploration, which is what are the different things I can do, with exploitation, which is what is consistently working really well. And reinforcement learning should be able to explore the search space in a very smart and efficient way compared to, how we might do it. So all of these make it like a really good setup for reinforcement fine-tuning.